For example 5, again, it looks like we have two binomials. The first terms are square root 6 times 3 square roots of 6. So this one is a little bit different. We better be careful here because with this first distribution, 6 is under the radical. That means it's being multiplied by the other 6 that's under the radical. Do not multiply it by 3 because 3 is not under the radical. 3 is actually multiplied by our invisible 1 that's outside the radical here. 1 times 3 would give us 3. And under the radical, 6 times 6 is 36. So I hope you can see what I did there, what terms I combined. 1 times 3 cleared the radical, and that's where this 3 comes from. 6 is multiplied by 6, and that's where 36 comes from. Our next distribution, square root of 6 is multiplied by square root of 2. So the terms that have cleared the radical, 1 times 1 would be positive 1, and under the radical we have 6 times 2, which is 12. Now we're going to distribute negative 4 square roots of 2. So the terms that have cleared the radical are the negative 4 and the positive 3. That makes minus 12 outside the radical. Under the radical, 2 times 6, that's 12. Last, we're going to distribute negative 4 square roots of 2 times positive 1 square root of 2. The terms that have cleared, negative 4 times positive 1 would make negative 4. Under the radical, we multiply 2 times 2, which is 4. Now let's see what we can do to simplify any perfect squares or any other numbers that fall under the radical. With our first term, 3 times square root 36 means 3 times 6. That's 18. No radical remains there. Our next term is 1 square root of 12. But notice how the two terms in the middle have a common radicand. So when we talked about adding and subtracting, we knew that we needed common radicands. These are common radicands. So here in the middle, we're looking at 1 minus 12. So 1 minus 12 would be minus 11 square roots of 12. Remember, we're just copying our common radicand, and we're combining the coefficients, 1 with negative 12. That's where negative 11 came from. Finally, our last term, minus 4 times square root of 4. So that's minus 4 multiplied by 2. Let's see if we can simplify anything else here. 18, we did everything we could with 18. 12, are you thinking maybe we could break that apart? Let's see, 4 times 3 would be helpful because that's 2 square roots of 3. So in the middle, we really have minus 11 times 2 square roots of 3. The last term, 4 times 2, is 8. So we're subtracting 8 at the end. So 18 minus 8, those are like terms. That makes 10. But in the middle, we could go ahead and simplify even a little bit more. Negative 11 times 2, that's negative 22 square roots of 3. In example 6, we have more binomials to work with. And our first distribution is square root 7x times square root 7x. So the only term that's outside of each of these radicals is positive 1. So it's up to you if you want to write the 1 or not. I would have 1 times the square root of 7x times 7x, or 49x squared. Next, distribute to this last term. And now we do have a term that's outside of a radical multiplied by a term that's exclusively under the radical. So that's minus square root of 7x. Next, we'll distribute positive 1 to each term. So here we would have positive square root of 7x And 1 times -1 is -1. Look what happens here in the middle. We end up with opposite terms, therefore they cancel. And we're left with square root of 49x squared minus 1. Now simplify if you can. You probably recognize 49 is a perfect square. So 7 will clear the radical, and also x squared is a perfect square, so x will clear the radical. So this term of square root 49x squared is equivalent to 7x. Our last term is minus 1. You may notice that we really started with two very special binomials. The only thing that was different about these binomials was the sign that connected the terms. One had plus and one had minus. Remember back when we were doing our difference of squares? We ended up with the middle terms canceling, and that's exactly what happened here. When the binomials are written almost identically except for the signs being different, you can expect your middle terms to cancel. In our last example, we have a quantity squared. This is the formation of the answer when we had perfect square trinomials. All of those factors were perfect squares. All of those factored into binomial squares. What it means to have a quantity squared is that you just have two identical quantities. So 3 square roots of 7 minus square root of 2 is multiplied by 3 square roots of 7 minus square root of 2. We're going to distribute the first terms. So 3 times 3 are outside of the radical, giving us a product of 9, while 7 times 7 are both under the radical, giving us the product 49. Now we'll distribute to the last term. 3 is multiplied by -1, that is outside the radical, and 7 and 2 remain under the radical as 14. Next, we'll distribute the square root of -2. The terms that have cleared are 1 times 3, so that's a -3, because it was -1 times 3. And 2 times 7 would be square root 14 under the radical. Our last terms are negative times negative, so that gives us plus. -1 times -1 would be plus 1 out of the radical. Under the radical, 2 times 2 is 4. So let's see what we end up with. Just scanning it, what do you notice? Hopefully you notice something here in the middle. Those are identical. The terms have doubled. And we end up with some perfect squares in the first and last terms. So we really have 9 times 7 for the first term. At the end, we're adding 2, because the square root of 4 is 2. So here in the middle, -3 square roots of 14 minus 3 square roots of 14. We have a common radicand, which is square root of 14. So what term goes in front of that is the combination of our coefficients, -3 and -3. That's -6. Now, is there any way to break down 14 that would be useful here? Factors of 14 are 1 and 14 or 2 times 7. There are not any duplicate factors, so there's no perfect square factor for 14. That means that middle term is already simplified. So the best we can do here is actually multiply out 9 times 7, which is 63, and combine that with its other like term, +2. So this final answer is going to be 65 minus 6 square roots of 14. And that's how you can multiply with radicals.